Hello programmers, Spidy is back with one another video. In previous video we have seen about how we can deploy the DeepSeek model over AWS EC2. Now in today's video we are going to see how we can deploy a specific scikit-learn model over the AWS Lambda function, and that will be serverless. You will be paying a cost whatever number of API calls that you are going to make. So this is going to be very cost effective in terms of the scalability. Also you can have the Lambda scalability, and it will be available 24/7 and you will be paying for a cost whatever you are going to invoke. So this is going to be very cost effective solution, and we are going to deploy ML inference, but make sure that this is only for scikit-learn model, or model is or the option in option that model is having a very less size, less than 250 MB, then and then this will work. Otherwise Lambda will throw you the error of having packages more than 250 MB. So without wasting time, let's get started. So now as you can see in the thumbnail, we are going to train a scikit-learn model. So now in this video I'm not going to focus on how I'm going to train a model or which data set I'm going to use. I assume that you might be having your own model with scikit-learn with any of the algorithm, either it is SVC or random forest. So what we are going to do, we are going to use AWS SAM over here. So AWS SAM, if you don't know what is it, so it is serverless application model. So we are going to do it step by step. Now I assume that in step 1, first of all, we need to train a ML model. Either it can be done on local or SageMaker or Google Colab or any of the inference or ML training environment. I assume that you need to train a model. So we are going to use my local machine. So I'm just going back, and I have already created a tutorial 4 if you are not following me. So there are already SageMaker tutorial series, and now this is tutorial 4. So I have already created directory, you can see tutorial 4, and now there is a ML inference app. I will explain all this SAM application structure later. Now, but if you can see, this is a train application, train file. It is actually using iris dataset, which is coming from scikit-learn only, as I told. I'm just going to train this. It's very simple code. I'm not going to deep dive in this code. Just like you can see, this is the logging that I'm enabling, and then after logging enabling, I'm just loading the data set over here, and then I'm splitting into the train and test, and then I'm adding the standard scalar and logistic regression as a classification, creating a pipeline .fit and getting some model metrics like test accuracy or classification report. And at the end, this is very important step, I'm dumping my model as a Joblib. Either it can be Pickle also, but Joblib is a safer way to play or dump the model and play as inference. So yeah, so if I'm going to run this, let's see. Yeah, and now you can see the model is trained with Python 3.11. Now we need to make sure that in which version you are training your model. So if it is 3.10, 3.11, 3.12, or whatever version of the model is, you have to remember this. As now you can see the model is trained. I'm not going to much more get focus on the accuracy, but the accuracy seems nice. 0.93 on test data set, and now you can see now model is already saved. Now what we need to do, let me go back to the step 1. We are done, we have the model. Step 2 also we are done, we have serialized the model. Step 3 also we are done. As I mentioned earlier, we have to remember the version of a model, either it is Python or scikit-learn. So make sure you remember the Python version only, it is enough. If you wanted to be more specific on, so just make sure you remember the scikit-learn version, because this version and this scikit-learn version we have to use in our Lambda environment as same. Otherwise you will face a different errors on if you are using a different version of scikit-learn, maybe older version, and so those dependency issues will be there. So make sure you remember. Now implement the Lambda inference handler. So let's back. So before creating or before going to creating the inference, I would suggest let create a particular structure of my ML inference app. So SAM is following a particular structure, so you should have one folder, like example I'm taking as a ML inference app. Now in inference, in this particular folder you should have a particular template. Now template is nothing but a YML file, which I will explain later. It is kind of a CloudFormation stack. Now inside this particular ML inference folder you should have any folder. I'm just naming it as a API. Now in that API folder you have to put your requirement.txt, and make sure you are not adding much more requirements which is not useful or not needed. Otherwise you will see the error of 250 MB, since Lambda environment is limited to 250 MB if you are not going to use the Docker. Since this is not a Docker way, make sure you are adding the only needed requirements over here. So scikit-learn and pandas are needed for me. Now in API folder you need to also have one more folder called lambda underscore functions, and now it should have one init.py like initialization file. It should be empty. It is fine. Now you have to place your pickle file or joblib file of your model inside this folder. Now you can see I've already done that, and now this is a inference lambda function handler. Now this lambda function handler, I assume that it will be attached on an API gateway, so it will be taking a request body from the user. It can be multiple instances, kind of request body. So now you can see I'm using these all are the default libraries. I'm importing joblib, enabling the logging. Now make sure that you need to use a path and get the default directory to access this model inference, whatever your file name is. If you are going to put slash and then you are trying to access, it will not work since you are in a lambda container environment. So other things are, I mean, you can see like getting the load model joblib dot. This is how I'm loading the model, and these are like parsing the event and predict. Just example, loading the model and getting the prediction, getting the production prediction probabilities. These are the things. I'm preparing my response body. This is the function. Now this is most important part. This is my lambda function handler, and you can see this is I'm counting the timestamp as well, and turnaround time for my API. I'm logging some event as well. If my event is not proper, I will make it response back. Otherwise, then I will process it. And once I got the prediction, you can see I'm just calling the predict method. I'm providing instances I will be getting from the user means API request body. Once I will process the request body, I will make the prediction over here, and once the prediction is done, I have to return a response body. So for returning a response body, I have to create a particular result dictionary. Now in the result dictionary, I will return the labels, and also I will be returning the probabilities of that particular prediction. So remember that it is supporting the multiple request body. So in example, you can send 10 rows, 15 rows as a prediction, you will get the same. And now I'm returning the timestamp and TATMS, like millisecond of my entire API request and response. So just I can measure the performance of my API and logging down the result, and this is the exception. So in exception, I'm just returning the exception. If there is anything, it will return as a API response. Now once it is done, yeah, so once it is done, you are done to deploy this as a API. Now before deploying this API, make sure you open your terminal. I'm just referring this PyCharm terminal. Let's see what we can do over here. So first of all, I would like to just make sure that you should have valid things are installed, like AWS CLI, and if you should have also credential. Just example, I'm checking my credential AWS S3LS. It will give me the available buckets with me. So as I can confirm that this I have credentials of my AWS account. If you are not having, you can go to this AWS console and you can get your credential from creating a IAM user. You can just go to IAM and create your credential. I think it's very simple step. So just let me go back to the flow. So as per the flow, we are done with the step 3, step 4 and step 5 also. We have prepare the particular SAM structure as well. Now once SAM structure is done, let's see for the SAM CLI. So if you don't have installed SAM, you can also download the SAM. You have to download from the AWS website. It's very easy. So now I confirm that I have AWS and SAM dependency both installed. Now as let's go back to the template.yml file. This is the main structure of your particular you can consider your CloudFormation. So let's see from the beginning. So this is the initial structure. Now this is my function timeout, memory size. Memory size means how much memory I'm going to allocate my lambda function. Inference storage is 1024 MB. I mean kind of a storage, kind of UEBS or network storage that you are going to attach to a lambda function. Now resources, this is the name of a resource, and the name is serverless function. Properties, I'm just giving the description. Code URI, this is very important step. So code URI name is API, since my folder name is API. In your case, if your folder name is something else, just example test1, then you have to add test1. Now there is one more thing. If you see, now I have given the folder name lambda function. So in handler, you have to first mention your folder name lambda functions, then dot, then you have to mention your file name. In my case, my file name is Inference lambda handler. So you can see the same name, and then there is a lambda underscore handler. Now this lambda underscore handler is nothing but your function name, which handler that you have created over here. So if example I have lambda underscore handler instead of I have something else, then I have to mention that in my template.yml file, but it is a best practice to have this as a lambda handler. And now make sure, this is very important step, if you have trained your model on Python 3.7 3.8, you have to mention your runtime version specifically over here. So in my case, I think I can mention 3.10, or I think 3.10 or 3.11 also works. So 3.10 is also fine with me. So it doesn't make much difference, but if you are training on 3.7, or then you have to mention the older version, whatever you have trained. Now inference route. So I have to attach a API. So API, to attach API gateway, you have to define type API properties. In path, it should be inference. So slash inference will be route of your ML model. Method will be post, and architecture will be this 8664. Now policies that I'm going to attach with my lambda function is s3 full access and lambda basic execution role. Actually it's not needed, I can remove the s3 full access also, it's not needed. Don't give unnecessary policies to your lambda function. Now metadata, this is very important step. Your build method should be your same, again Python version 3.10. You have to give a path of your requirement.txt. It is very important. So in my case, obviously your requirement.txt should be outside of this specific lambda function and inside of API. So inside of API, my requirement.txt is there. I have given that part. And now this is very important step, pip install args, and I have given no depths. What is this meaning, no depths? So if you go to requirement.txt, so scikit-learn and pandas, sometimes it install unnecessary dependencies also, which is we don't require, even scikit-learn also or pandas also don't require, but still it install. So as I have limitation of size of 250 MB, I have to make sure that it shouldn't be installing any of the unnecessary requirement. So what should I need to do? I have to mention no depths over here. So it will only install whatever is needed. And this is output. Yeah, so I'm done with my template, I'm done with my understanding of SAM layout, and now I'm also done with the step 6 and 5 also. Now let's move to the step 7. We are going to build and deploy. So let's get back to over here. Let me just make it more. So now you can see, just make sure you are in the right directory. Now what you have to do, you have to cd to your application folder. In my case it is ML Inference app. Again check with ls, you should have this folder API and template.yml file. Now already have copied command also. I think I have given also in my GitHub repository as well. You can see the command over here also. So same command you can use over here. Now while building, it's best practice to mention your file name. Now you can see there is a use container is mentioned. Use container, it means it will use the Docker, and I would always recommend to use a Docker. So you just download a Docker desktop, and let's see, let's say build use container. It will take some time for a first time, and what it will do, it will actually build the dependency. So after some time, once it is done successfully, you will find .aws-sam folder in your application. Yeah, and I can see my build is done. And now if you see aws.sam, as I mentioned, it's created, it will have build folder, and you can see this is your lambda function environment, and the same environment will be running in the lambda container. And now you can see all the dependencies like pandas, numpy, whatever is needed for my code and whatever is needed by the dependency, it installed, but it doesn't have unnecessary dependency which is not required by scikit-learn or pandas. So yeah, that's all. And now what I need to do, again I have to deploy this into my account, and now there is a simple way. Just copy this command. So now you have to mention your stack name, which is your CloudFormation name. Resolve S3, it will use the default bucket. Capabilities, it will automatically assign the IAM role, and region is AP South 1. You can change your region as per your expectation. Let me just put this. By default, I'm not mentioning my profile name since I have my profile AWS account is default. But if you have your example, you have different profile of AWS credential, then you can mention -- profile and then name of your profile. So let's enter. It will take some time to deploy. So let's see. It depends on the internet, since it will download this entire dependency and put this into the S3 bucket. So it depends on your speed of internet. So let's wait for a while. I think it's almost going to done. Till the time, what you can do, you can go to your console of your function, and then you can look over here, and now you can see my ML inference stack is in progress. So make sure you monitor this properly, and you can see it started creating the function IAM role. It will take some time. It depends on the number of resources. In your case, if you have multiple Lambda functions, so it will take time accordingly. And if you don't know how to do this, there is another way. You can deploy this with a guided way. So if you can see, I have added a guided over here. Guided will ask you some question, and you just have to mention your answer in why or no, yes or no. It will give you the particular yes and no. Based on that, it will deploy the stack. So if you are new to AWS SAM, I would recommend to go with guided, but if you know AWS SAM, just go with this command. So let's wait for a while. I think it would have been done. Let's refresh, and you can see ML inference stack is deployed. And now you can check the resources, and these are the resources that's been created. Now you can see role, then there is a one more REST API is created, and my Lambda function is also created. Let's see one by one. Let's go to Lambda console and check the API gateway as well. So now you can see, as I mentioned, runtime is Python 3.10. This is the name of function. If you wanted to get your custom name, I mean, it will be get by AWS only, then you can remove this particular name from function name. So it will get the default name as your stack. And now you can see my function is already attached to API gateway, and you can see this is your inference URL. This can be used in your Android application or whatever downstream application, you can use it. Now if you see code, it will not display your code, and since you can see packet size is 74 MB, and you can see it's not inline editable over here. Now let's test this application. So just you should do it with Postman, or if you have Python script also, you can do that. So as I mentioned, it is supporting actually multiple rows. So if you see, this instance is a list, and you can see it is having the multiple, I mean 2 rows as of now. I'm concluding. Let's copy the URL. And my method is post. Let's see, I will not get any error, I assume. So for first invocation, it will take some time since it is loading some scikit-learn model. And now you can see I got response in 9 seconds. This is the initial. Now you can see prediction 0, 1, and probability is like 0.90% accurate, 0.74% accurate. At timestamp and millisecond is around 7 seconds. Now, but if I'm going to make this API call now, one more time, let's see. And now you see the latency, 75 millisecond, which is less than half second. So you can see now I'm getting latency in less than second. So it is the default behavior of Lambda runtime. So in first initial, it will take some time to load your model, and then if it is continuously getting traffic, it will be get response in less than 1 second. Depends on your written code, the standard practices that you are following. And if you wanted to make it 24/7 available, just example, if you have heavy model, you want that key, I should get latency in less than 5 seconds. What you can do, you can enable the concurrency and enable the provision concurrency. Provision concurrency will keep your Lambda function active 24/7. It is taking some percentage of the charges, which is still less than comparing to owning the EC2 server. But yeah, you can enable the provision concurrency as well. But as of now, to test it, I don't need it. But you can see my API is working well. And now if you see in terms of the architecture, in terms of the implementation, I have hosted my AWS ML model on the serverless function. Just example, if this model is getting only 100 request in a day, still it will be cost effective, because 100 into 0.001001 something cost that you are going to pay. So now it will be 24/7 available for you. Still it is cost effective and serverless. So that's how it should be. Now in terms of the API security, what you can do, in go to API gateway console, you will find your API. You can enable the securities like burst or usage plan or API keys. Those things you can add it by your own, or you can add it by in your CloudFormation, or I mean in SAM template, depends on your expectation. But overall, yeah, this is what the implementation in last I think this video is almost now 20 minutes, but you can see in last 20 minutes what we have done. We have created ML model from the train, and then we have deployed this over the SAM. And you can delete this tag once you are done with your experiment. Since this is serverless, it doesn't cost me anything, even though if I'm going to put it as for last maybe next 1 year also. So that's what about this video. So in initial, let's just summarize this. So in step 1 we have trained our model in local. Step 2 we got the save model. Step 3 we have taken the note of Python and scikit-learn version. Step 4 we have created Lambda inference handler. Step 5 we have created SAM directory. Step 6 we have created SAM template. Step 7 we have built and deployed the SAM template. In 8 we have validated and tested the API. So that's what all about today's video, and guys, see you in the next one. Until that, you can just subscribe Machine Learning Hub to get this kind of videos, AWS related, ML or Python related. And if you have any question, you can just put comment down, or you can reach out to me on LinkedIn. All these links are given in the description. Thanks for the listening. Bye.